All right, we want to prove this big thing. It's given us that n is greater or equal to 1. So we'll start off as usual, start with our step 1, show it's true for n equals to 1. So I'm going to put n equals to 1 into this, which is our general term for the left-hand side. So left-hand side will be negative a half to the power of 1 minus 1. 1 minus 1 is 0. Anything to the power of 0 is 1. Now the right-hand side, put n equals to 1 into here. So I have something like this. Now you know that negative half to the power of 1 is just negative half. So it's going to be 1 minus a half, which is 1 plus a half, which is 3 on 2. 3 on 2 times its reciprocal, which is 2 on 3, is of course just 1. Okay, so just do a little bit of calculation there. And therefore you can see that left-hand side is right-hand side. We can show it's true for n equals to 1. Now the assumption, assume it's true for n equals to k. Replace n with k, and that's what you should get. And that's our assumption. Because our step 3 needs a little bit more working, I'll actually just put this over here. This is equal to that. Okay, so that's our assumption. So I'll just write step 2. All right, so show it's true for n equals to k plus 1. So it's going to look like this. There's going to be 1, all the first part's going to be the same. So up to here, it's actually the same as what we had in the original question, but make sure it's k, not n. But here, when I do k plus 1 minus 1, I get just k. So that's why that's just k. So that's what happens there on our left-hand side. And on our right-hand side, we simply have k plus 1 instead of just k. So let's go ahead and prove it. So left-hand side is going to be all of this, which I changed into this. Because have a look, guys, I'll use a different color. See how all of this is the same as our assumption, which we have over here? That's exactly the same. That is, and that is this, which I'll put into that red box there. So this goes into there, which is now here. Okay, so that's all that. I just simply use my assumption, and that's how I did that. And have a look at our right-hand side. Always trying to compare with the right-hand side, because eventually our goal is to make it the same as the right-hand side, isn't it? You can see that the right-hand side has 2 over 3 outside the whole thing. So I'm going to try to have 2 over 3 outside the whole thing. But see how this one? If I want to put that into the brackets, I got to find the factor of 2 on 3. So if I take out 2 on 3, I can put 3 on 2 into here, because I know that 2 on 3 times its reciprocal, which is 3 on 2, it's eventually just going to be 1. See how there's an invisible 1 there? So therefore I made this 3 on 2, so I can put it all inside the big bracket. So I basically factorized by 2 on 3. Now you can see, guys, that over here, this and this, it's like terms. They're exactly the same. They're like terms. So see how this is minus 1? So I simply need to do minus 1 plus 3 on 2. Minus 1 plus 3 on 2 is a half. So I have half, negative half k. Okay, so the like term just follows at the end. So that's what I did. So it's a little bit more simple now. So hopefully we'll get somewhere. Now, have a look, guys. This half, this is positive half. Now you know that half is negative a half, because negative eventually makes positive. So what I'm going to do, and you'll see why I'm doing this, is this. I changed this part here to this. That's what happened here. So I did negative a half, which is eventually just positive a half. But the reason why I'm doing this is because I want to make this the same as this. Okay, so can you see now they're the same? So if I have those are the same, and you can see that this has a power of 1, I can gather them together because we're multiplying. Using our index laws, we know that we can just add the indices when we're multiplying. Okay, so it's eventually just going to be negative half to the power of k plus 1. Okay? And now compare it with our right-hand side, which is that one. Is it the same? Yes, it is. It's simply the right-hand side. So we've just proved it for for part 3 for n equals to k plus 1. Now I didn't put a conclusion there because I'm running out of space, but I'm pretty sure you guys can write the conclusion by yourself. It's going to be similar to what we've done in the previous question. I won't go through the conclusion, you guys can work that out yourself.